Hello, I am Yu Yang, who is the presenter to introduce our paper, a peak post-estimation model for measuring peak's body size. As the current production scale increases, it is realized that it is difficult for farmers to continue to adopt traditional methods of animal monitoring, and new digital technologies are required. The large-scale and intelligent modern management mode is the way to improve production efficiency and reduce the cost of pig breeding. As an important evaluation index of pig, body size is still many obtained by manual measurement, which is inefficient and difficult to measure. Therefore, the research of non-contact automatic body size estimation method is necessary. Our contribution in this paper mainly consists of three parts. First, we built a big key point dataset, and we proposed a set of key points suitable for peak body size measurement in the image. Second, we proposed a network header structure integrating canning operator, and added the triplet attention module to the downsampling module of the algorithm. Third, we achieved 93.4% average precision on our dataset. Compared with the baseline model, we achieved a 9.2% improvement. Now, we'd like to introduce our work from 5 parts. First is how to create dataset. Second is how to realize key points detection of pig. Third is how we optimize our algorithm, and fourth is to show our results in pictures and video. The last is to compare our algorithm with other algorithms. When we contribute our dataset, firstly, we collected pig images in the Shandong Oasis pig farm located in Zhenjiang City, Jiangsu Province, China. Next, in order to expand the data diversity, we obtained images from online dataset and added them to our dataset. There are a total of 1,000 images in our dataset with a total of 5236 labeled pigs. The resolution of pictures in our dataset is 3840, 2160, or 1920, 1080. In our dataset, we split the training set and test set by 4 to 1. The training set includes 800 images and 40 19.7 labeled pigs, and the test set includes 200 images and 1139 labeled pigs. In our labeled process, compared to the traditional measurement of pig body size using only 5 points on the pig's ears, front legs, and tail, we added a point at the center of the pig's back scapular for labeling, as shown in the two figures on the right. The body size of pig can be represented more reasonably after adding the modified points. The selection of the characteristic point at the center of the scapular is shown by the two figures on the left. By using the image edge information extracted by the canning operator, we can find that the edge exists at the scapular when pig is standing, and their invisible dents exist at the outline of the pig at its scapular when pig is sidelined. Therefore, it can be considered that these points have certain characteristic information for key point detection. The framework of our method is shown in the figure, composed of a network header, a downsampling module, and an upsampling module. Our header consists of an image and a canning channel. The image channel comprises a 64-layer convolution. The canning channel comprises a 32-layer and a 64-layer convolution. which input is the edge information calculated by the Canny operator. The downsampling module comprises receiver and triplet attention modules responsible for feature extraction. The upsampling module comprises three the convolution layers, which is responsible for outputting heat maps containing key point information. As shown in the figure, a model for peak key point recognition is constructed in this paper. The orange and purple branches of the network represent our header structure, and the blue module in the network represents the receiver module added with the attention mechanism. The gray trapezoid represents the convolution layer. As shown in figure, our network header includes two branches, the image channel and the Canny channel. We add the Canny channel into our header. In that way, the network can obtain adequate edge information and better identifying key points. After two convolution calculation branches extract edge information and image, the two tensors will be added and input into the downsampling module to extract features. In our downsampling part, the main structure is still receiver network, but we add attention mechanism to it. We add triplet attention module to each receiver unit of the module, as shown in the figure below. Similarly, the CBAM used in the follow-up experiment was added to the baseline model in the same way. As the figure shows, the pictures we used to compare the key point recognition have different light intensities, peak densities, and peak postures. In the figure, we used red circles to mark incorrect key point detection in peak images. As for the baseline algorithm, there are many errors detection in results. As for the baseline algorithm combined with CBAM or triplet attention mechanism, there are relatively few errors in the results, but there are still some problems, such as key point deviation and not on peak bodies. As for the algorithm which header is replaced by the structure proposed in this paper, through comparison, its result is better than the previous three algorithms. Moreover, we can find that our algorithm has a better recognition effect when the lightning conditions are darker, the peaks are dense, and the peaks are in bending angle postures. In the video, we show the recognition results of peak key points in the video by the algorithm, and we find that the algorithm's performance is still good. We trained a YOLO V4 model to detect peaks in the video. Then we used the output information about peaks location and frames of video to recognize key points of peak. Comparison of results on testing set from baseline and baseline with attention mechanisms shows that the AP scores reached 92.8% with the triplet attention module and 91.6% with the CBAM. Compared with the baseline model, they increased by 8.6% and 7.4%. Since the model's performance is better when the triplet attention module is added, we have added the triplet attention module to our model. The curves show that the convergence speed and detection accuracy of the model is greatly improved after adding the attention module, and the triplet module can get better results than the CBM. Comparison of results on our testing set from baseline and baseline with triplet attention module and header proposed by us shows that our network header can achieve better results. After using our network header in the baseline model, the AP and AR scores increased by 2% and 1.8%. Using our header in the baseline model with the triplet attention module, we also achieved 0.6% and 0.2% improvement in AP and AR scores. The curves shows that after using our network header structure, the average precision of the model is improved, and the convergence speed of the model is also improved. The model using our network header and adding the triplet attention module achieved the best result. Let me take a summary of our work. First, we built a big key point dataset, and we proposed a group of key points suitable for peak body size measurement. Second, we proposed a network header structure integrating Canny operator and add the triplet attention module to the downsampling module of the horizon. Finally, we achieved 93.4 average precision on our dataset. Compared with the baseline model, we achieved a 9.2% improvement. Thank you for your attention.